Hi, everyone, and welcome to the 24 Hours of PaaS Summit Preview. We're excited you could join us today for Oscar Lee's session on an introduction to global data quality. This 24 Hours of PaaS event consists of 24 consecutive live webinars delivered by expert speakers from throughout the Professional Association of SQL Server community. All of the sessions will be recorded and posted online after the event. You can go to 24hoursofpaas.com to actually view those. Just as a quick introduction of myself, my name is Anil Desai. I'm an independent consultant based in Austin, Texas. I do a lot of work with SQL Server and .NET development, and also have been a Microsoft MVP for 12 years in the area of cloud and data center management. Okay, so I have a few introductory slides before I hand over the reins to Oscar so we can get started. So first, if you have any technical questions or issues, just feel free to type those into the chat pane that you have available. If there are issues that I can handle, I'll be happy to answer those for you. Otherwise, I'm going to save them for Oscar until the end of the session so he can go on unless he pauses to ask for those. So I'll respond to you one way or another. You can also maximize your screen if you can't see the detail in some of the slides. And there'll be a short evaluation following the session. Okay, next I'd like to thank all of our sponsors, Quest, Melissa, and Nutanix. I'd like to draw everyone's attention to the poll that has appeared on your screen. This will actually allow you to interact. So while I'm speaking, feel free to answer for your chance to win a $100 virtual Visa gift card. This session is brought to you by Melissa Global Intelligence. Melissa Global Intelligence provides data quality and identity resolution tools for SQL Server and .NET to perform the tasks of ensuring new incoming data is in good condition and maintaining data quality over time. Wanted to mention that the staging of 24 Hours of PaaS would not be possible without the support of all of our sponsors. Okay, and just wanted to mention a little bit more about PaaS. You can get more information on PaaS.org. It's a not-for-profit organization and provides a wealth of year-round learning opportunities to data professionals. So there's tons of stuff to know about SQL Server. It's a great place to go to find more information about that, and also to look for local groups and online virtual groups that you might want to join. Can help you in your career and help your organization as well. Okay, and lastly, before I turn it over to Oscar, I'm going to mention the PaaS Summit itself. And this is going to be taking place in Seattle, Washington from October 31st to November 3rd. And it features over 200 sessions from world-class experts. It's a perfect place to connect, share, and learn from industry experts from around the world. To find out more information, just go to PaaSSummit.com. Okay, with the introduction of that information out of the way, I'm really proud to turn this over to Oscar Lee, a product channel manager at Melissa. His title is Introduction to Global Data Quality. Take it away, Oscar.
Thanks, Anil. My name is Oscar, and I'm from Melissa Global Intelligence. Thanks for joining, and welcome to Introduction to Global Data Quality. So today we're going to go through the core fundamentals of data quality and learn about the role that it plays in today's information industry. I will also introduce 6 core concepts of data quality along with the full data quality lifecycle. We will showcase some possible implementations of data quality through SSIS. And lastly, we will learn about how globalization plays a role in affecting your data. So first, what exactly is data quality? It is a growing data science field and plays an increasing role in the information industry spectrum. Over the last 30 years, we've seen enormous growth in the data quality landscape. Major companies are increasingly worried about the integrity of their growing data sets. You can think of data quality in a nutshell to be the data's fitness for use, the ability of the data to serve its purpose. Data quality can be applied to all types of data, including scientific, consumer, business, financial, geographical, and etc. Through data cleansing techniques, we will be able to achieve data quality. Data quality plays an integral role with its siblings data governance and master data management. The MDM and DQ disciplines are closely related. This means that they can be usually seen working together with each other in tandem. You'll rarely see MDM implementation without data governance and data quality. Data quality plays an important role to both disciplines. Recently, we did a survey with our customers to see how to use data in their businesses. Majority of clients use their data quality to focus on improving revenues and improving service to their end businesses and operations. However, we can see other notable use cases for improving your data quality, such as marketing, risk reduction, channel pipeline, new projects, and compliance and regulatory. So there's a rule that's called 1, 10, and 100 rule. This rule describes that it costs $1 to verify an address at the point of entry. It costs $10 to cleanse and deduplicate in a batch setting, and $100 to do nothing. This is the cost of using bad data. I'd like to introduce what we call atomic domains of data quality. In short, this describes the data at an atomic level. There are simple atomic types such as age, dates, sales that are very familiar to most people. And there are also complex atomic types like SKU numbers, part numbers, and item numbers, which require a very good understanding of your own business and the industry in order to formulate rule definitions for your data sets. These are atomic domains that require special handling and utilizes available domain-based knowledge. For example, Social Security number and IP addresses have a specific format that is standardized across the US. There is domain knowledge of how they should be formatted and how many digits they consist of. Address-centric atomic data is also a good example, as there are many rules pertaining to what is considered a good address. On top of that, this rule may vary across different countries. So you have to be careful if you're working with a global data set. So you can see that it's not so trivial to handle these atomic domains. In order for data quality regimen to be successful, you must not treat all data as the same. Each has a different set of rules and formats, which will, if not put into place, will result in bad data quality. While most atomic domains can be handled by third-party data quality experts like ourselves and other vendors out in the market, these advanced atomic domains are extremely hard to understand and work with. Product items, assembly numbers, part numbers, and SKU numbers. To work on these atomic domains, you must have inherent knowledge in that industry. For example, a data quality expert may not know the hardware industry well, the hardness of the screw, the pitch size of the screw, the type of screw, and the metal composition, and so on. For tackling these types of problems, it's always prudent to team up with the data quality experts and involve industry experts to generate domain knowledge to be used in data quality. Now that we know about the different types of data at an atomic level, I'd like to introduce the 6 concepts of data quality. These 6 concepts lay the foundation on which data quality builds on. They are completeness, conformity, consistency, accuracy, integrity, and duplication. These course fundamentals ensures that you have the right information and don't have conflicting information across data sources. Promoting the use of a single source approach to information so that customers enter their information to be stored in a single location. This means if the customer updates their information, they're updating the master record, and all uses of that information is updated. Let's go over completeness. So completeness is asking, is all the information available? Is there missing values? And the values that are missing makes it unusable. In some cases, missing values is not necessarily critical, but when information that is missing is critical to a business process, maybe you're trying to do calling and you're missing phone numbers, then completeness is an issue. Conformity. This is the expectation that data values conform to specified formats. And Maintaining conformance to these formats is important in data representation, presentation, reporting, and analysis. If you have values that are laying in outliers and they're because of bad data quality, and you're trying to display them in reports and graphs, it can skew the graphs and make it not look as nice as if everything was within the specified expectations. Consistency. This is asking if all the data instances are providing the same kind of information or conflicting information. Are values consistent across data sets? Inconsistency between data values will make it harder to reconcile between different systems and applications. So it's very important to keep data consistent. Accuracy. Do data objects accurately represent the real-world values that they model? So incorrect spellings, incorrect addresses, out of date will affect operational and analytical applications. So very, very important that accuracy is maintained in data, in your data. Duplication. If there is multiple and unnecessary representations of the same data objects in your data set, if you can't maintain a single representation for each entity, it poses numerous vulnerabilities and risks. Maybe you're not selecting the right person, maybe you're not selecting the right record per se, the right record for transaction amounts and things like that. So having a single representation for a single record is very important. Lastly, integrity. So what data is missing? Important relationship linkages. So the ability to link records together will help and reduce deduplication. So there's more value derived from analyzing connectivity and relationships between two different data types, and it really impedes the ability to have this valuable analysis when you're not able to confident with a high confidence level link these two data sets together. Like this phone number and this person is actually associated with each other. If the data is not integrity is not intact, you cannot make that confident assumption that this phone number is indeed associated with this person. Data is always evolving and changing. To trust in static data is a very risky move. One major root cause of data quality issues is time decay. Chronic data quality is always in flux. Individuals die, marry, and divorce. People and companies move. More than 40 million Americans, or 1 in 6, move annually according to the USPS. As a result, data that was once good quickly grows stale, with the quality of stored US addresses declining 17% every year. This is reported by USPS. Email addresses are being activated and deactivated. Phone area codes are being split and disconnected as people change their service. So it's not always static. Data is always in flux. And you can see in the pictures some examples of boundary redrawings from the government and how zip codes can change over time. So now that we have the core fundamentals of what is considered data quality, it's time to introduce the full life cycle of data quality. These are steps and procedures to successfully implement a good data quality system. We have profiling, data hygiene, data verification, enrichment and updating, matching, merging, monitoring, which completes the cycle. The first step in data quality lifecycle is to get a health report on your current data. In order to do this, you will need to profile your data to see what kind of data types you're working with, and also see where the outliers are in your data. We can identify which data feeds has issues and generate pattern regexes to see which streams are coming in not standardized. By profiling your data set, you're getting very valuable statistics that can point you in the right direction for your subsequent data quality processes. These are some basic metadata statistics you should keep track of. There's column structure. These types of metadata provide information on proper table formatting for a target database. It is considered problematic, for example, if an incoming table has values that exceed the maximum allowed length. Missing information. Missing data can be synonymous with bad data. This applies, for example, where an address line is blank or null. In most cases, is considered a required element. Duplication. This allows for indication of duplicate records. Deduplication is a standard practice in data quality and is commonly considered problematic. Ideally, there should be only one golden record representation for each entity in the data. Ranges. Certain fields may only accept a certain maximum or minimum range. Data that is beyond the allowed possible threshold should be subject to investigation or correction. Find out why this is happening. Spaces. Unnecessary spaces must be considered for standardization purposes. Spacing discrepancies may prove problematic, for example, when doing table lookup for exact matches. Casing. Casing is also an important piece of data quality standardization. For Canadian postal codes, for example, it is recommended for the data to be in uppercase. Invalid character set usage is usually an indication for bad data. Next is pattern. Regex representation allows for identifying deviations from formatting rules. Dates that are in different formats can be easily determined through regular expressions. Similarly, value patterns allow for more exact identification of proper formatting. Take, for example, US state abbreviations. They must follow the pattern AA, where AA is 2 capitalized alpha characters. Statistics. These statistics allow for gaining a basic understanding on the trends of data, such as gathering statistics for income ranges provides knowledge of average income, as well as how spread apart they are. And last but not least, frequencies. Frequencies give us an overview of the distribution of records. It allows us to view the most and least frequently occurring values and lengths. This can be used to determine trends in the data to generate reports like gathering the value frequency for age to provide information on common age range demographics from your customer data. Here's an example of useful metadata. In the first table, you see that the header names give no indication on the type of data within each column. It can also be true that order of columns without proper header names and format can be ordered arbitrarily. In order to understand this data, the only solution is to manually investigate the contents of each column. This is necessary to import and consolidate with other data. To automate this, you must also be able to automatically detect the contents within each column. And the metadata that is produced is the inferred data types. If you were to invert the 5 columns in the sample table, it would yield the following results in the table like below. In this example, we see a statistical metadata values on a table. Knowing how many unique values in our database will be helpful in determining the need for deduplication efforts later downstream. So you notice that we're keeping track of how many unique names, how many unique addresses, city, state, postal, and country. And you kind of get a sense of what your immediate need for deduplication is from these metrics. Next is hygiene. Data hygiene is one of the most important parts of data quality. Proper casing, formatting, and standardization will affect structured data and deduplication efforts later. Fixing misspellings, correctly parsing out fields, and standardizing abbreviations will get better results when you enrich and update data. So there's a couple of cleansing techniques you can utilize. Here I'm showcasing generalized cleanser component within SSIS that is created by us, but to kind of showcase what kind of features you should be looking at or developing when developing on your own. Punctuation is adding or removing punctuations from your data. Standardized abbreviations whenever possible. For example, the states, California to CA, New York to NY. Search and replace to standardize data such as company names. For example, Rite Aid Corp, Rite Aid Business, etc. Use regex rules if you already have expression built in order to extract extra information or validate data. For the adventurous, you can also use order operations to link multiple operations together and set triggers for when these rules should be run. Here's an example of the abbreviation and casing operations being performed on the table on top. Notice that not all the cases are fixed. You should have multiple rules to handle every scenario you can kind of think of. If you recall earlier about the domain-based knowledge that I mentioned, generalized cleansing versus knowledge-based cleansing, this concept also applies to cleansing. Definitions for what is good and bad data is not as clear-cut as the more generic rules. An address is a good example as it requires intimate knowledge of the structure of the address in order to know if it should be fixed or not. Likewise, with email domains that follow the RSC standards or the universally followed conventions, the time and development costs on complex domain rules are not trivial and should be only undertaken by a large engineering team with years of experience. There are many companies that are dedicated for providing these tool sets for these specific domains for those who do not want to develop in-house. With data-driven cleansing, sometimes using static reference data to formulate your own rules could result in big issues. So instead of using internal rule sets to parse addresses, it will be far better to use an authoritative reference data from licensed vendors or USPS directly. These vendors have PAV and CAS certifications, which means you can be assured that these addresses are being parsed out, fixed, according to standards that is set by the USPS themselves. Here's an example of several iterations of the same address. Below, you should see they should all standardize to the record field below. So 2205 E La Palma Avenue, apartment 236. And you notice that there's a lot of issues in the before, and top one has some @ symbols and casing issues. So when it's all done and fixed, all 5 records should look like this. Here's an example of removing invalid characters and parsing the name correctly. The bottom is how the name should look. Here's an example of removing invalid characters, fixing syntax, misspellings, and casing the email correctly. The bottom is how the email should look. So if you're doing email cleansing, you should account for all these potential issues and even more. Here's an example of removing invalid characters and formatting the phone number correctly. The bottom is how the phone should look like. So there's various formatting, invalid characters, extension type of issues when dealing with phone data types. Not only should we care about how the data looks, but also if the data is verified or not. After we fix all the issues in the data, we now have to ask if these addresses actually exist. Are the phone numbers downloadable? Are the email addresses active? Is this name a nickname or their actual name? after each data is validated individually, you should try to correlate pieces of information against each other. So here we have example of address verification, the top one being a valid address after it was corrected. So 22382 Impreza, and it got corrected to 22382 Avenida Impreza. On the bottom is not a valid address. So this is how address verification should somewhat look like. There is name verification. Is it being parsed correctly? Is it last and first or first and last? And of course, there are issues with fictional names like Mickey Mouse and other stuff that you don't want to be your clients to be inserting into your databases. There's email verification, making sure it's a valid and active mailbox. For example, on the bottom, it's a fake domain and pretend that the mail server does not exist. Even though syntactically it's correct, it may not be a good email. And here is an example of phone numbers being validated and formatted. So on the bottom, you can see even though it's formatted correctly, it might not be a dialable phone number. Here's some examples of records being cleansed and then verified on kind of a batch basis. If you noticed MD result columns, so what you want is a kind of response column that says if the data is valid or not. And then you want to have a secondary fields for your stand and cleanse version of the original input. Enrich and update. Because data becomes outdated over time, usually data sets are missing pieces of information. Having the ability to enrich and update records is key to maintaining quality of your data. Appending in to fill in missing data pieces like phone numbers and email addresses could be critical to your operations. Enrichment data such as demographics could provide your marketing team a much better 360 view of your customer. So some examples of updates and moves is this person right here used to live at this address. Now they live at this address. Changes in area codes, rezoning. So having the correct area codes is pretty important. And also sometimes domains are renamed, and you will need to be able to capture those updates to the domain on the email level. Here we see an example where phone numbers and email addresses are appended to the original data set on the top. This improves the quality of the data. So anytime you can improve on adding in more relevant information, it could be useful later down the line as well for deduplication purposes and just having that extra pivotal piece in order to do additional operations on. We move on to matching. Duplicate data is simply bad data. Matching serves to identify duplicate data and to properly merge records in a safe manner. By leveraging deep domain knowledge, you can handle international data and data across other domains more efficiently. So the kind of matching process you should be kind of a guideline to follow is first you specify the rules to see if the records are matching. Next, you determine the data types that to leverage in order to leverage domain-based knowledge for better matching results. We use a technique called golden record to decide what is considered duplicate and what should be considered the golden record. Next, we use survivorship technique to save critical data and consolidate records. Lastly, we want to filter records based on results. going to a new master table, and a list of records that still needs to be worked on. Here's just a quick and simple example showcasing what deduplication might look like. Basically, you're removing duplicate records from your data sets. But even though I have it in this example, everything is the same. In your data sets, there might be small variations and small things that are not exactly right, which makes it a lot harder to then just do an exact match kind of deduplication. Merging is a step after matching. You will need to decide what can be removed from the data, merged or kept. There are two advanced techniques when it comes to merging, golden record selection and survivorship. The golden record technique is used for selecting the best record amongst a group of duplicate records as your remaining master record. What this allows is to have a single accurate representation of each entity in your data. So here we have an example of golden record last updated. So what this means is from all these records in the top example, we're taking, even though they're all the same, we're taking the last updated one to be as considered a golden record. Anything older than that should be considered a duplicate. And you can see that the record containing MSO2 is the ones that was selected to be the golden record. You can also do a golden record most complete. This technique allows to select multiple columns for evaluation, and basically it would choose the record with the longest concatenated string. So looking below, you see that the name Joseph Doe is the longest one, and address is all the same. So this is why the first record is selected to be the golden record. There's also golden record data quality score. So this technique allows you to select golden records based on the quality of your data. Now, in order to do this, you must be able to leverage results from your previous verification process in order to score the records and decide which records to keep. And you can base it off of, you can create your own algorithm to base it more on address, you can skew it towards name, and you can weight, consider them all equally. And there's a bunch of different combinations you can do based on your business needs. Now that we've decided we have a golden record, what if that golden record is missing a phone number or email that the duplicate record does have? Using survivorship, you can consolidate pieces of data together into one record so we do not lose that information. So, for example, if you look at the first table, you have 3 records, and then using golden record selection with the latest update, you would select the one with the last update. But if you also set survivorship for the longest name and greatest amount, you'll be able to get the Mr. John Doe. Even though it was not in the golden record, we're still getting that longest name and the highest, greatest amount. And so we're populating this golden record with the remaining records that is considered the duplicate, but might have better information for certain aspects. There's a couple different techniques for survivorship. There's first data. Basically, this one gets the first value available. It orders the values according to your priority, and then selects the first value. This one is first non-empty. So basically, it gets the first non-empty value, and it gets the first value that is not null. This one concatenates the values together with the join technique. You can join pieces of data together. You can join with spaces. It orders values according to what you want, and then joins them together, delimited by spaces. This method is usually used if you can't create more than additional fields in your current schema. Add is pretty useful if you're trying to consolidate inventory across 2 warehouses. Basically, this one finds the sum of the values of all matching records. So factory A, B, and C, they have this inventory of this shoe. Add them all together to get a consolidation of the inventory count. Average is useful to average duplicate records with differing sales numbers. So you have, the same branch having different sales numbers for that same month. You don't have any backups. The best thing you can do is perhaps average them out. The most frequent one, this is useful for deciding the highest probability which transaction amount is correct. It finds the most populated value of this column and uses that as the consolidation. There's also stack group. So this is useful for storing multiple addresses or key pieces of data for that contact record. It will create additional fields for matching values and consolidates them into a single record. So this is kind of useful if you have this person, but you have multiple addresses, multiple phone numbers. You don't necessarily want to get rid of them, and they're all correct, and you don't want to lose any one of them. I would use a stack group kind of technique to save them all. So here is a demonstration of data quality practices that we have learned so far. In this table right here, we see we have a bunch of names and just some missing piece of information, and sometimes the name is reversed. So first we identified that we need to standardize the names. So let's go ahead and do that. Once that's done, we need to standardize and correct the address. So here we're doing that. And we enrich and append missing pieces of information. Now we match and merge and get a single entity like so. So you can see how we're applying all the techniques earlier that we saw to kind of to duplicate and get a single entity. The data quality lifecycle is a continuous process, and you will need to profile your metadata in order to see how data quality process is improving your data quality and where you need to spend more time on. Typical data quality is done by validating against either internal or external systems. These systems will consider the data you received, provide corrections, or issue notifications to your application flow. With SQL Server, you have options to build in data validation process or use a third-party vendor component within your SQL Server integration services project flow. This validation will work through the data presented and correct it automatically or provide exception reporting and suggestions. It's important to understand that different systems work with data at varying levels of comprehensiveness. There's a couple of decision points that will help kind of determine, and it's do you want your validation to be in real time as user submits their form? Do you want your validation routines at the server level? Will you have US or international addresses? Things like that. Here is an example of using our in-house components for constructing a data quality system and how it would look like in SSIS. When we are leveraging pre-built components in that previous example to reduce development time and efforts. So now we're getting into a topic called global data. So global data is a very interesting aspect of data quality. It introduces new challenges and you're forced to learn outside your own domain. For example, address formats are unique per country. Some fields that might have been critical in the past for a country might not be as important in another country. Need to address Unicode character sets in your database as well. So let's approach this subject without any knowledge of international addressing. Not all countries have established postal systems. In some countries, the mailman is so familiar with the building or neighborhood by just going on the same mail routes for past X number of years. A simple name could be enough. In other countries, postal standards are so strict that one item off the address can mean that the mail would be undeliverable. Some countries with good postal systems include the US, Germany, the UK, and some countries with not so good postal systems include Brazil, India, and Italy, to give you kind of a sense. Most source data is available from the post office. This means that standardization of addresses is possible by the general public. However, some countries' postal data is state confidential, and you'll be hard-pressed to find accurate data reference. For example, the Chinese government provides incorrect geocoordinates for certain sensitive areas, which is offsetting latitude and longitude by a certain amount. Some vendors and technology firms are trying to reverse engineer and solve this issue. But even if the country does not have the best postal system, their postal service is probably aware and really adapted to the deficiencies in the postal system. So you kind of have to adjust your expectations accordingly. So what normally makes up an address? It consists of area, street number, building number, and here's an example of the way that address is constructed. However, now with the introduction of global address, these terms are standardized a bit differently. The most important parts of a global address would be country, postal code, administrative area, which is also known as state or province, and the locality also known as city. Any other pieces of information would be useful for using global address standardization toolkits in order to make corrections and enrichments. So postal codes are frequently pure numbers, but sometimes they're mixed in with special formatting, whether it be dashes or alphanumeric or alphanumeric and dashes. Not every country uses postal codes, and it's not always based on a hierarchy either. So you have to be careful when dealing with postal codes and having certain assumptions about postal codes. Here are some countries that require postal codes, the number of digits they want. Some have an alphanumeric, and notice that some countries don't even use postal codes. International streets is also referred to as thoroughfare. They might have leading types. Types might be attached. Names can be much longer than if you're in the US, what the US and Canadian street names could be. Occasionally, they can be a dependent street like Seasone Court and Station Road. Where on the street? So building numbers, there's a variety of formats. You can have a building number, you can have hyphenated, slashes are very common in Europe. Sometimes you have landmark references, Bank of New Delhi. Sometimes a building name is necessary in order to locate where on the street this address actually is. Where in the building? Now that we identified a building, we need a house number. And the order and placement often differ than the US. Sometimes it's house first and then apartment, and then it's unit 2 and then house 7. So you have to be careful when dealing with different countries and not just being aware of it could be in different orders. Sometimes there can be multiple levels, staircases, floors, and apartments as well. Post offices, there's some standalones out there. Usually it has the area plus the box. Some require a street address, so area plus a street plus a box number. There's usually an indicator phrase and a series of numbers like PO box, things like that for post boxes. Here's some tips for dealing with international addresses. Try to design a schema not based on your own country's postal standards. Prepare at least 8 address lines to be allowed. Don't bother keeping the address parts separately. Chances are they're parsed out incorrectly to begin with. However, do keep the area pieces. So this is administrative area, city, state type of area types, as this will be key in enrichment and correction for the data quality processes. Don't change between languages and scripts. Every time you do so, you risk losing data. It's extremely encouraged that you change your database to support UTF-8 Unicode from the get-go instead of changing scripts. Never truncate your data. It's far more useful from a data quality perspective than having truncated data. Try to account for extra space. The world is a big place, and there are many different types of naming conventions. Allow for a very generous column size because space is simply cheap. However, data coverage is very expensive. Here are some extreme examples of long city names in the world, and there are much more. So when you're trying to build this from the ground up, everything that we learned, don't assume encoding types. If you're trying to work with global data, I recommend using Unicode strings for most fields. Store the formatted address given by an address parse toolkit. You do not want to read how each address is formatted per country. I really recommend going to a third-party vendor for this, as there are over 241 countries in the world, and each address is formatted differently per address or per country. When dealing with global address fields, the fields would be much longer than the US or Canada. Proper encoding can make or break your global data quality project. You will need to be consistent and convert carefully. Do regression testing on your encoding and asking the question, once I encoded this, are the same addresses that coded or validated earlier is still coding the same? If it's breaking that, then maybe something with your encoding is wrong. There's a transliteration versus translation. Transliterate is the pronunciation of a word. Translation is the meaning. Transliteration is commonly found in a lot of global address toolkits to provide when dealing with other scripts other than Latin-based. In terms of data quality, I recommend to keep a native script if possible. However, in emergency, use transliteration. Never use translation. Possibility of having everything in one field. This is a very common, I see it all the time when dealing with clients that are not familiar with global data. They tend to store everything into one field because they're not sure, they don't want to make a mistake in parsing it out and so forth. You may encounter scenarios where global data is coming in from a single field line. This stems from developers and data providers not knowing how to handle global address data. For this, we recommend third-party engines to parse out the address correctly. Development time and costs are very high when you deal with over 241 countries' international data, postal standards, and rule sets. Basically, you need years and years of development time in order to know how to properly parse out an address for every single country. So global data matching, you can also leverage country level knowledge to improve your matching and merging. You can standardize to the country's postal standards to get where they're supposed to be. Be sure to leverage company names, phones, and emails wherever possible. You might also want to transliterate your records to see if you can get any matches as well. And as you can see down here, you can see that we are deduplicating based on a country, specific abbreviations. We're substituting those tokens in order to see. We're standardizing all the address data from other countries in order to get better matches. And these are just some things you can do to help increase your match rates. All right, so this kind of concludes my presentation on global data quality. Thanks for listening in. Now I'm going to hand this back to moderator, Anil.
Yeah, thanks, Oscar. That was a great presentation. It covered a lot of important things that I think a lot of us database people run into with data quality. So thank you for that. I've been able to take care of most of the questions that have come in already. So I think we can conclude a little bit early, unless you have anything else that you wanted to add at this point. We have about 5 minutes left, or I can just go ahead and conclude right now. It's up to you, Oscar.
If there are no other questions, right now I don't have anything, but in case anyone has any questions specific to global data or just the data quality concept, feel free to email me at oscar.lee@melissa.com, and I'll get back to you.
Great, thanks, Oscar. And I'll remind everybody that's attending that we will have a recording of this available as well. And coming up next is going to be a session called Why Did My Clever Index Change Backfire? And this is going to be presented by Kendra Little. And so that'll be starting in roughly about 5 minutes or so. Thanks so much for attending, and a special thanks to Oscar for all of this great information on data quality.
Mm-hmm.